In this video, I'm going to go over on what intervals is the function increasing, decreasing, or constant. What does that mean? Well, we're talking about domain and range, right? Sort of just pieces of it, though. The domain focuses, if you've seen my previous videos, focuses on all the different values of x that we can have in this graph. And the range is all the different values of y that we can have, right? I'm including them because we need to understand the difference between the intervals, right? Because we still write what we're increasing on, decreasing, and constant on in interval notation, and local maximum, local minimum are different. So, what does it mean to be increasing? Well, when we read things in English, we read from left to right, right? So, if we're increasing, we first look at it from going from the left, moving to the right as we go through the domain, right? All the values of x. And is our graph going up as we move from the left to right? Then it is increasing. If it's going down as we move left to right, then it's decreasing. And if it's just flat, that would be constant. Okay? Does that make sense? So, from the far left point, which is negative infinity in the domain, right? Negative infinity. All the way up to this point, because then it starts decreasing, right? All the way up until this point, we are increasing because we're going up as we move to the right, right? Even though this arrow is pointed downward, we are increasing. Does that make sense? Because it's always from left to right, always from left to right. So we're increasing on the interval negative infinity to what? Well, -1, -2, yeah. That's a -2 because it's domain, right? So it's always the x value. You don't say it's increasing from negative infinity to what, 1, 2, 3, 4, 5, 6, 7? Because that's the range. That's the y value. We want the x values when we're talking about increasing, because it's the x-axis that we're talking about when we're talking about whether it's going up or down, right? So we're increasing from negative infinity to -2, okay? Then we start decreasing, right? From -2 to where? 1, 2, 3, 2.5? Let's say 2 and 2.5. Yeah. Positive 2.5. And sometimes you might get an answer like that. You know? It's right in between 2 and 3. All right. Then what? Now we start increasing again, right? Because we're going up as we move left to right. So we're increasing on that interval in union with this interval from 2.5. Ah, messed up there. Not done yet. To positive infinity. There we go. And it's constant nowhere. Now, first of all, let's review domain and range. What is the domain of this graph? The function on this graph? Well, we went from negative infinity to positive infinity, right? On the x-axis, it's including everything. We got an arrow over here and an arrow over here. Yeah, all real numbers, okay? arrow going to the left, arrow going to the right includes all real numbers and everything in between. And nothing is repeated. So it is a function. We know that. What about range? Range. Well, it's going kind of downward as well, this arrow. So it does include all the negative infinity y values, right? It comes up here and kind of repeats itself, right? Because we're including all these values and then all these values again. And then all these values a third time. But that's okay. It's just not a one-to-one function. But it does include all those values down below, and this arrow is kind of going up and to the right. So it also includes all positive values. So all real numbers, domain, all real numbers, range. That was easy. Local maximum, local minimum. That's kind of important because we kind of needed to know where those were so we could figure out which numbers we're using in our intervals to describe where the graph is increasing and decreasing again, right? But I know we use the x values, but the local maximum, local minimum, that's asking for the y values. Now, it's not the maximum because the range is all real numbers. The maximum is infinity and negative, and the minimum is negative infinity. But we call it a local maximum and minimum because that's what's important when finding out, where our increasing and decreasing stops and starts. So we said -2. 1, 2, 3, 4, 5, 6, 7. Yeah. So the local maximum would be 7. It's a local minimum. 1, 2, 3, 4, 5. It's about 5 exactly. The local minimum is -5. That's -5. All right, not too shabby. All right, here's another example of a graph because I wanted an example that included some constants. You can tell someone was having a little fun with a piecewise function here. Just completely different functions from one certain interval to the next. Okay, maybe 1, 2, 3, 4, maybe just 4 different sections minimum. Anyways, so real quick, what's the domain here? From the left to the right, do we include all numbers? Yeah, we got arrows going left and an arrow going right, even though they're going, upwards. We do include negative first, all real numbers in the domain. What about range? See, both arrows are going up, so there's some lower y values that are not being included. Yeah, they never go lower than this line here. So what is this? 1, 2, 3, 4, 5, -5, huh? Okay. So starting from the lowest point, we include -5 and we go to positive infinity in the range. That's fine. It's still a function, right? No domain values are repeated. And it's not one-to-one, though, just like our last one. But, yeah. Thus is what happens when you're practicing increasing, decreasing, and constant function reading. All right, so start from the left, go to the right, and just make notes of everything, okay? Maybe we could start with our local maximum and minimum. Maximum would be what? 1, 2, 3? Okay. Any other maximums? Nope. Minimum? Okay, we got -5 here. We already mentioned that. What about over here? 0. -5 and 0. There's more than one minimum. Okay. All right, I think we're ready to figure out on what intervals where increasing and decreasing are constant. So start from the left, always start from the left. We're at -infinity, right? And we go all the way to here. And what are we doing? Are we increasing or decreasing? We are decreasing, right? Because we're going down as we move from left to right. Down. And we stop right here, -1, -2, -3, right? Yeah. So we are decreasing from -infinity to -3. Okay. Now what are we doing? We're just constant, right? We're constantly stuck on -5. So we go from -3 to what? +1, right? And we're just constant that whole time. And now what are we doing? We're going up as we move from left to right. So we're increasing from +1, because we're always using x values, not the y values. From +1 to what? 1, 2, 3? Yeah, 3, +3. Okay. Now what are we doing? Keep going to the right as we move. We're decreasing here, right? Because we're going downwards from left to right. So I already had a decreasing interval, so we have that in union with this decreasing interval. 3, 4, 5, huh? So it goes from +3 to +5. Now what? Now we're increasing again. That in union with +5 to what? Infinity. So we included, we have included the entire domain because we started at -infinity and we've included every piece of it. Well, yeah, -infinity, -3, -3 to 1, 1 to 3, 3 to 5, 5 to infinity. So we started at -infinity, ended on positive infinity. That's kind of how I check to make sure I concluded everything. Thank you for watching.